AI models are highly capable but operate in complete isolation, locked inside their neural weights without direct access to external databases, APIs, or files. This boundary restricts their ability to solve real-world problems effectively. A new open standard, the Model Context Protocol, changes this paradigm by introducing universal connectivity, allowing AI models to securely interface with any data source. Today, integrating AI with tools is fragmented. Every application developer has to build custom integrations for every specific model and API, which is highly inefficient, costly, and difficult to maintain. By establishing a unified integration standard, we can dramatically reduce engineering overhead, making connections between AI models and datasets reusable and scalable across any environment. Just as the HTTP protocol revolutionized the early web by creating a universal standard for sharing documents, the Model Context Protocol establishes a universal standard for AI interaction. It creates a standardized language that allows models to query data sources, call tools, and handle context uniformly, regardless of the underlying platform. MCP shifts the integration paradigm from point-to-point connections to an open, hub-and-spoke ecosystem. Instead of writing custom API wrappers, developers build an MCP server for their tool, which automatically exposes its resources to any compatible MCP client. This architecture turns complex enterprise integrations into plug-and-play connections. The architecture of MCP is built on a clean client-server model. The MCP client, which is typically the LLM application, initiates communication with the MCP server over standard transports like JSON RPC. This protocol abstraction separates the model reasoning layer from the data source implementation, ensuring security and transport flexibility. At the heart of the Model Context Protocol are three primary building blocks: resources, prompts, and tools. Resources provide read-only access to files and databases. Prompts offer standardized templates to structure the model's context, and tools enable the model to execute actions and modify state in external systems. When an MCP client connects to a server, they perform a dynamic handshake called the discovery dance. The server advertises its capabilities through a manifest file listing all available tools and resources. The AI model reads this manifest and adapts in real time, instantly utilizing new capabilities without code changes. Security is a core design pillar of the Model Context Protocol. By running servers locally or in containerized sandboxes, MCP keeps sensitive credentials and data access under the client's direct control. The user remains in the loop, explicitly approving tool execution and data access queries before they reach external systems. MCP serves as the agentic glue that transforms passive chatbots into active, autonomous operators. By standardizing how models discover and execute functions, MCP enables multi-agent systems to collaborate seamlessly, sharing tools and passing structured data back and forth to solve complex, multi-step objectives. For developers, MCP is a massive leap forward in productivity. Instead of constantly rebuilding tool integrations for new model releases, you build an MCP server once, and it instantly works with Claude, ChatGPT, and other LLMs. This shifts developer focus from writing boilerplate integration code to building core product logic. Operating in an MCP-driven world requires robust and scalable runtime infrastructure. MCP servers can run locally on developer machines, on cloud microservices, or within isolated secure sandboxes. This flexible deployment model ensures that enterprise systems can scale their tool endpoints while maintaining high availability. With MCP, integration efficiency is measured in seconds rather than weeks. Standard benchmarks assess server latency, tool discovery speed, and execution reliability. By optimizing these connection metrics, developers can build responsive, low-latency AI applications that feel instantaneous to end users. Because AI models can discover and chain tools dynamically, MCP enables self-assembling workflows. When presented with a complex prompt, the model automatically selects the best sequence of tools across different servers to complete the task, creating dynamic execution paths that no developer had to hardcode. Large enterprises struggle with unlocking legacy databases for AI agents. MCP solves this by wrapping legacy systems in a secure, standardized server interface. Once wrapped, these internal systems are instantly accessible to any AI model, dropping the marginal cost of new AI integrations close to zero. Enterprise deployment of autonomous agents requires strict governance. MCP provides granular access control, allowing administrators to define permissions and audit logs at the protocol level. You can monitor exactly which model accessed which resource, ensuring compliance and preventing data exfiltration.